Hello, this is FlippedHarber for Algebra 2. In this video we're going to talk about logarithmic expressions and functions. The objectives for this lesson are to write logarithmic expressions and equivalent exponential expressions, write, graph, and evaluate logarithmic functions. The outline for this video will talk about what logarithmic and exponential expressions are. We'll talk about something called the common logarithm, the natural logarithm. We'll take a look at logarithmic functions, as well as take a look at graphs of logarithmic functions. Here we see a combination of exponential expressions on the left and logarithmic expressions on the right. And really, these are called equivalent because from every exponential expression, we can create a logarithmic expression. And vice versa. For every logarithmic expression, we can create an exponential expression from the same terms. So on the left, we see a to the m power equals b, and on the right next to it, we see the log base a of b equals m. 2 cubed equals 8, and then on the right, we see the log base 2 of 8 equals 3. Now, I like to think of logarithmic expressions as being inside-out exponential expressions. And when I see something like the log base 2 of 8, I think about it as it's asking what power should I put on 2 in order to create 8. So I'm looking for a power to go on this base number that's going to create this large number. So that's why the log base 2 of 8 equals 3, because 2 with a third power, 2 times 2 times 2 is equal to 8. So here we're going to take a look at some exponential and logarithmic expressions. You should write these down. These help you to learn how these two expressions are related. So we have 2 cubed equals 8 as an exponential expression, and the equivalent logarithmic expression, log base 2 of 8 equals 3. So here's all of the exponential expressions we're going to look at. Some of these are special cases that I want to talk about. So 5 to the first power equals 5. As a logarithmic expression, let's try to compare to the exponential expression above it, the 2 becomes the base on the logarithm. So what number is in the same spot? Well, this 5 is in the same spot as the 2, so this 5 becomes the base on our logarithm. The 8 is inside the logarithm. This logarithm is operating on the 8. Well, where's the 8 at over here? Well, the logarithm's going to act on this 5. And then finally, this is equal to the 3. It's equal to the power. So this logarithmic expression is going to be equal to the 1. So here is the equivalent logarithmic expression. Log base 5 of 5 equals 1. And this is a special case. Whenever the base number and the number inside the logarithm match, it always equals 1. What power do I put on 5 to get 5? Well, I put a first power on there. So whenever these two numbers are equal, we get 1. Alright, what's our logarithmic expression going to look like for this one? Well, it's going to read the log base 6 of 1 equals 0. This is another special case. Whenever you take the log of 1, so it doesn't matter what this base is, if you take the log of 1, it's always equal to 0. Here's another one. What's that logarithmic expression going to look like? Well, the log base 3 of 1 over 9 is equal to a negative 2. The point behind showing this one is to show you that logs can equal negative numbers. And as a matter of fact, whenever this is a whole number and this is a fraction or a decimal number, you'll always get a negative answer. Okay, now let's talk about something called the common logarithm. Whenever you see a log with no base, that's what's understood to be the log base 10. The only reason that this is the common logarithm is because we use base 10 math. So whenever you don't see a log base right here, it's understood to be the log base 10. So this would just be read the log of b. And it implies that it's base 10. This over here is read the log base 10 of b. Well, mathematicians are kind of lazy. If they just agree that whenever there's a 10 down here to not write it, it can save some time. Now the natural logarithm, whenever you see an ln, this is actually French for, logarithm de naturel or something like that. It's the natural logarithm, and it actually means the log base e. Now e is a special number. It's approximately 2.71828188284. It's non-repeating, non-terminating decimal. It's like pi. It's just a number that shows up a lot in math. So because it's an irrational number that shows its ugly little face quite often, and it shows its face in logarithms a lot, we decided to give it its own special name. It's kind of like that scruffy dog that comes to your house enough that you decide to keep it. So whenever you see a ln, that's read the natural logarithm of b, or the natural log of b, it means the log base e. This is built into your calculator. If you actually find the ln button, it's going to be the natural logarithm. Now let's talk a little bit about logarithmic functions. A logarithmic function is one where the variable is inside the logarithm. It's not part of the base, it's inside the logarithm. So this log base b is acting on the variable. Now here's some examples of logarithmic functions. We could do any log base we want. We could do a log base 4 of x. We could do a common log, the log of 2x. So the 2x is inside the logarithm. We could put a number in front like we have here, so 4 times the natural log of x. These are all logarithmic functions because the variable is inside the logarithm. It doesn't matter what base we're talking about, and we can put numbers inside the logarithm with the x. We can put numbers outside the logarithm, like on this one. If the x is in any other location, it's not a logarithmic function. So x log 4 is not a logarithmic function. This is actually a straight line. It's just a straight line with a really weird slope. So this is not a logarithmic function. Just because it has a log doesn't mean it's a logarithmic function. This is not referred to as a logarithmic function either because the x is in the base of the logarithm. This would actually be kind of ugly. We could do it, but it would be difficult. So this is not a logarithmic function either because the x is in the wrong spot. It should be right here where the 10 is. Alright, so all that's left is to talk about the graphs of these logarithmic functions. Now these are some basic logarithmic graphs. Here we see the log base 10, the common logarithm. We see the log base e, better known as the natural log. And we see the log base 2. Now all three of these curves have a lot of stuff in common, as all logarithms have. They all go through the x-axis at 1. As long as you don't have any other numbers added or subtracted or multiplied in here, they always go through the x-axis at 1. They all approach the y-axis but never ever cross it. These graphs can never touch or cross the y-axis. Now if we did some transformations, then they could move past the y-axis. But without any transformations, they all approach the y-axis without touching it, without crossing it. Now here you see the y = 1 line kind of dotted across here, and the point is that at y = 1, this blue curve is at x = 2. Well, it's a log base 2. So it goes through at 1. So really what this is saying is the log base 2 of 2 is equal to 1. Here the log base e, the natural log of e, is 1. And then this yellow curve right here, the log base 10, the common logarithm of 10, is equal to 1. Okay, so we're all set. It's time for you to try some of this stuff on your own. I'll see you in class and I'll see you online.